everybody, it's a lovely day, Zia here, and in this video, we will be talking about wave in physics. So, in this video, I will mention the big question, the two wave interactions, which include reflection, interference, and then also the real demonstration and real-life application. Let's begin. By the end of this video, I hope that we can answer the big question and also be able to get this outcome, which is able to implement phenomena of waves and lights in a physical and geometrical optics phenomenon to provide a future forward innovation. Let's start. So the big question is, why might visionary leadership cause and or affect transformation? Let's keep this for now, and we'll think in the perspective of wave in physics. Okay, so the first wave interaction is reflection. Reflection in physics is when a wave bounces off a surface or object. So this is the surface, and there will be a normal line. A normal line is the line that is always 90 degrees from the surface. And then come an incident wave, and after the incident wave, it will bounce on the surface and it will become a reflected wave. And also, the incident wave is always the same degree to the surface than the reflected wave to the surface. Next is interference. Interference is when two or more waves meet while traveling in the same medium. So, there's two types, which is constructive interference and destructive interference. And here, the blue and green lines are the two waves that are mentioned here. They're traveling in the same medium, and when they meet, they will construct and become a bigger wave. As you can see, it's the red one. While destructive is when these green and blue meet and destruct each other, so they cancel out, and it becomes a straight line because the wave is now not present. I mean, it's just canceled. Okay. So this is a demonstration of reflection in real life. You would look at a mirror, or you would look at a glass, and you would see a reflection, and it will seem as if you are in front and behind this surface. Well, it's not. It's the light that's reflecting off the mirror to you. So there will be light that goes to the mirror, and it will reflect, and you will see it to your eyes. And this is important in daily life because you would want to be tidy, neat, and presentable in a social instance, and also be healthy. And you can check that by looking at your skin and eyes and all that. Next is interference. So my demonstration is bubbles. So in the next slide, I will explain to you how bubbles is a good example of interference. So basically, the thin film, there is a front side and a back side, right? This inner line represents the back side of the film. Even though it's thin, I'll just represent it like this. And this is the outer side of the film. So this line over here is the light that bounces once and is reflected by the film when it reaches the front side of the film, and this is the light that bounces off when it reaches the back side of the film. And how does this cause interference? Let's go to the next slide. So basically, this is the first wave. This is the wave that it bounces off from the front side, and then this is the wave that bounces from the back side. As you can see, the ones from the back side will have to go a longer distance, and so sometimes when it doesn't align properly like this, it will destruct each other. So this is the original line, and the line that is straight like this is when they cancel each other out. You know that the waves destruct each other when the bubble is clear and it doesn't have any rainbow. Next is constructive. So basically what makes the rainbow in the bubble is when The waves, the light waves that bounces off both the outer and inner part lining of the bubble aligns, it will become the colorful rainbows that we see. Okay, so that is the example. Now, let's talk about the real-life application. So, in reflection, a real-life application and development in technology is ultrasound. So, ultrasound imaging relies on the reflection of high-frequency sound waves to create images of inside the body. Sound waves are emitted and their reflection from the different tissue and organs are used to construct images. So if you ever assisted your mom, this is the tool that you use that emits the sound, and then you can see the thing on the screen. And this tool is really important in the medical field because it tells the condition of the baby or the condition of the organs that is in your body. So yeah. Next is interference. So another important technology and real-life application is noise canceling technology. Basically, some people get disturbed when there's loud noises outside and they need something to calm them down. And that is why the noise canceling headphone is really important. So how it works is there will be incoming noise from outside, which is represented by the red line, and then the second noise that is introduced by the headphone. So when it meets each other, it will distract and then it will cause silence, so you won't hear anything. Next, let's finally answer the big question. Why might visionary leadership cause and or affect transformation? So the answer is this. Visionary leadership, to me, is the ability to see and find problems from a perspective that other people don't see and then finally act on it. So the first step is, the answer is because first you have a perspective, and in this case our perspective is from physics. So by learning this physics and understanding a concept, you can apply that concept and solve daily life problems like the ones from before. There is noise canceling technology, which is a problem for some people. They don't want to be disturbed while environments can be noisy, so they created this technology. And also for the medical industry, you need to know if your baby is fine, if your body is fine, and you can do that using ultrasound, which visionary leaders use their perspective and understanding of physics with, and then they will create transformation. So I hope that in this video we could answer the big question and outcome together. Thank you, everybody.